Hello, my name is Muhammad AIMAN. Today I'm gonna talk about carbon steel. There's three types of carbon steel, which is low, medium, and high carbon steel. For the low carbon steel, the carbon content is up to 0.30%, and the characteristic of the carbon steel soft and ductile, which is it has a good weldability and machinability. Second one, for the medium carbon steel, the carbon content is between 0.30% to 0.60%, and the characteristic is balance between strength and ductility. It is higher in strength in terms of hardness compared to low carbon steel. And for the last one, high carbon steel, the carbon content is above 0.60% up to 1.5%. The characteristic, it has the highest strength and the hardness, which is it has a more brittle and less ductile compared to the others. And this is the example for the three types of carbon steel, which is low, medium, and high carbon steel.
So welcome, and today we're gonna discussing about high strength low alloy steel, or HSLA. HSLA steel is a type of steel that combines high strength with improved formability. It achieves this through the addition of alloying elements like manganese and chromium. The microstructure of HSLA steel consists of ferrite, and pearlite matrix with alloying elements precipitates dispersed throughout. This unique structure provides its excellent strength and formability. HSLA steel has a diverse application. It is used in automotive industry, for chassis frames and suspension systems, in construction for buildings, structures, and bridges, and in manufacturing equipment and machinery. In conclusion, HSLA steel offers a winning combination of strength and formability. Its microstructure and alloying elements make it suitable for various industries. Thank you for watching.
Hi, my name is PARAMASIVAN and I'm from group number 8. Today I'm going to explain about stainless steel. Stainless steel is a type of steel alloy that is highly resistant to corrosion and staining. It is composed of iron, chromium, and other elements such as nickel, molybdenum, and manganese. The addition of chromium to the steel forms a protective layer of chromium oxide on the surface, which prevents corrosion and gives stainless steel its name. Let me explain more about stainless steel. Stainless steel is known for its excellent corrosion resistance. There are different grades of stainless steel, each with its own unique properties. The most common grades are austenitic, ferritic, metallic, and duplex stainless steel. Next, stainless steel is strong and durable material. Stainless steel is widely used in industries that require high level of cleanliness and hygiene, such as the food processing, pharmacies, and medical sectors. Other than that, stainless steel is valued not only for its functional properties but also for its aesthetic appeal. Stainless steel is highly recyclable material. It can be recycled and reused without losing its properties. In conclusion, stainless steel is a versatile and widely used material known for its corrosion resistance, strength, hygiene, and aesthetic appeal. Its properties make it suitable for a diverse range of applications, from construction and transportation to consumer products and medical equipment. That's all from me. Thank you.
Good day to lecturer and friends. My name is Siva and I'll be presenting about the types of stainless steels. There are 5 types of stainless steels. The first one is ferritic, second is austenitic, third is martensitic, fourth is duplex, and fifth is precipitation hardened. The first one is ferritic. So these steels are based on chromium with small amounts of carbon and usually less than 0.1% of carbon in each of the steels. They cannot be hardened by heat treatment, and they have high chromium steels with additions of molybdenum can be used in quite aggressive conditions such as seawater. The next one is austenitic. Their microstructure is derived from the addition of nickel, manganese, and nitrogen. It is the same structure as occurs in ordinary steels but at much higher temperatures. And this structure gives these steels their characteristic combination of weldability and formability. The next one is martensitic. These steels are similar to ferritic steels in being based on chromium but have higher carbon levels up as high as 1%. This allows them to be hardened and tempered much like carbon and low alloy steels. They are used where high strength and moderate corrosion resistance is required. Then the next one is duplex steel. These steels have a microstructure which is approximately 50% ferritic and 50% austenitic. This gives them a higher strength than either ferritic or austenitic steels. They are resistant to stress corrosion and cracking. And then the last one is precipitation hardened. These steels can develop very high strength by adding elements such as copper, niobium and aluminium to the steel. With a suitable aging heat treatment, very fine particles form in the matrix of the steel which imparts strength. These steels can be machined to quite intricate shapes requiring good tolerances before the final aging treatment, as there is minimal distortion from the final treatment. Okay, next we will go to the grade series. Okay, so inside here we can see that we have the 200 series, 300, 400 until up to 600 series. So the meaning of this series is that from 200 to 600 represents a progression in terms of alloy composition, mechanical properties and corrosion resistance. As the grade number increases, they exhibit higher strength and improve in corrosion resistance. Okay, so the commonly used stainless steels are grade. Here we can see all the types of grades. For example, SS301, highly ductile for form products. For 302 we can see same corrosion resistance as 304, and then for example 309 we can see better temperature, and also from SS321 we can see similar to 304 but lower risk of well. So if we see the different type of grade, they have different type of personality, characteristics. So and their properties are also different. So from this grade, the manufacturers will choose which kind of steel that they want to use for their particular product. Okay, next I will give to my friend. Thank you.
Hello, my name is Muhammad FIKRI. I'm going to talk about aging process. So what is metal aging? Metal aging is a process used to change the physical and aesthetic properties of solution heat-treated metal alloys. There are two types of metal aging, natural and artificial. Natural aging occurs over a long period of time, allowing supersaturated alloying elements to form metal precipitate. During the natural aging process, supersaturated alloying elements within the metal alloy form metal precipitate, which block dislocation in the metal, increasing its strength and hardness while reducing its ductility. In contrast, artificial aging is accomplished by heating a solution heat-treated alloy to a temperature under the recrystallization point but high enough to form precipitate much faster. Artificial aging is a way of speeding up the process of metal aging with heat. The process involves getting the alloying elements in the metal to form precipitates, which increase the hardness of the metal and reduce its ductility. Any solution heat-treated metal alloy can be aged, including aluminum, stainless steel and copper alloys. Metal aging can alter both the physical and aesthetic qualities of a given metal alloy. Metal overaging is a risk associated with the process, which occurs when metal is aged for too long, resulting in a decrease in strength and hardness.